Oh, really? Yeah, so well, you're transferring, why don't you just
Hey everybody, can we grab some seats? Want to get started in like a few minutes? This mic? Or the mic? Which one is it to set up? They're all set up, but it's like, how do you want to present? Like,
yeah, let's
lapel? Yeah. Okay, let's just turn this on.
But anyways, like they're both like CS students, and I'm like, they're like, but I mean, a lot of companies will do it. But so yeah, I mean, it's.
I might be a bit short. There's time. Maybe not 30 minutes.
Well, I don't care. Like, I don't even. But like the recruiters, like for the college, I don't know. Mine. Yeah, like I took the C draft one, but just like that took like less class. But yeah, I don't know. But what I will say is like I don't ever.
Hey everybody, can you grab some seats? We want to get started pretty soon. Thanks everyone for coming out tonight. I know it's really cold. Awesome weather. And go ahead and close that door real quick. We got some pretty good presentations tonight, some React compiler, some animations, and some automation. So let's just get started real quick. So Capita Factory, give a shout out to Capita Factory. Finding venue space is challenging and it's always expensive. So appreciate Capita Factory providing it for free for us here on the 16th floor. Enjoy the view. Web Fountain's a consultancy that I have that I've been running since 2018. If you need any help with data API management, I specialize in Next, Node, Postgres, and Kubernetes. Happy to help. And and I also sponsor the Speed Up from time to time. Again, our food and drinks. Thank you to the Helper Bees. I guess what is the Helper Bees? Let's have the sponsor speak up.
All right. Cool. Thanks. Hi, I'm working. I'll keep this quick. So I'm Steve Sanderson, Chief Product Officer, run engineering and product at Helper Bees. So what is Helper Bees? We solve a problem about seniors aging in place. So the simple issue is if any of you have a mother-in-law, a father-in-law, father, mother, who's trying to age well by living at home, we're helping them. The way we do that is there's three groups of people we're working with. The first is a senior. They want to stay home longer. They don't want to go to a facility. They don't want to go to skilled nursing. That's a lousy change in their quality of life. So we know they have those needs. we pair them up with all sorts of different providers. We have a second side called our provider network. Providers and products, got like 25,000 agencies to work with across the country. And so a senior who might need help, say for instance, cooking, cleaning, maybe walking their dog, maybe they need a ramp built on their home because they don't walk very well, we'll pair them up with some providers that will provide that service for them in their home. That lets those people stay in their home longer, which has wellness improvements. They live longer and they live happier. The third group we work with is insurance companies. And some of you might be surprised to find out insurance companies are not totally benevolent. They actually try to make a profit. And the reason that they hire us is because by helping the seniors stay healthier longer, live in their home, it actually helps their financial bottom line. So the folks that founded Helper Bees figured out after much trial and error, they were here in Techstars, they went through a bunch of different programs, they found a sweet spot where the seniors who want to live longer, stay in their home, providers who want to make money servicing those seniors, and insurance companies who want to improve their financial bottom line actually all want the same thing. So it's one of those really rare triple bottom line kinds of deals. So that's the problem we're solving. We're roughly 200 people. Most of that, half or more, are humans talking to other humans. The product organization's got about a little over 15, 16 developers, 5 product managers. We just closed a C round, 35 million. We're across the whole country. We are trying to grow. We're trying to grow very fast. We're based in Austin, but we're fully remote. We just happen to be here. So you can see on the screen, we're looking to hire a director of product management. Tell your friends and family. If anybody knows somebody who's a product management director. Software engineering manager, same thing. Front end, we are looking for folks at a lot of different levels. Strong architecture on the front end, even at a junior level. We definitely want help there. Back-end engineering, we tend to look at the world as full stack is great. The reason we said front end and back end is people also tend to have an emphasis, like people more like front end, but they can do all full stack. It's great. Data engineering, I can tell you and bore you with all sorts of things about our culture. I'll do that offline. So that's us. Anyway.
What is the backend stack?
Take your pick. So let's see. We've got a chunk of software that's Python, Django. We have some stuff that's in Flask. It still hasn't gone away. We need to get rid of it. We have a whole nother stack of products that's built on more of a platform that's built on, don't hold it against me, C#, Angular. We're trying to improve that. And then, strangely enough, we have some sort of insurance-facing tools partially built on Salesforce that then use a bunch of APIs that we have. So it's a pretty thin, dumb layer. But the folks in insurance land love Salesforce. They think that stuff's really sexy. So we meet them where they're at. So that's the quick answer. Postgres on the Python side, Microsoft SQL. All of our data gets sucked into BigQuery, where we do all sorts of cool things with it. Yeah, that's kind of the big pieces.
When was the company founded?
9 years ago? Yeah, it's been around for a long time. We're actually based 41st and Guadalupe. So what's that? 39, 37, I can't count. Blocks north of here. In a very cool office, which nobody goes to, but it's a very cool office. It's at Quonset Hut on Guadalupe. If anybody knows Guadalupe, there's like Hyde Park Gym, just like a block north of that. Super cool Quonset Hut with like a happy bee painted on it with a big mural. That's us. Any other questions? We have really cool problems to solve. And I like working there.
What would be the next steps just for knowing more about the company and product?
So, gosh, that's a good question. I'm not sure I planned for that. Did this go out in email? It didn't because I got it. It will? Okay, so A, you go out an email. B, I'll be here. We can chat. C, you could go to the site and there'll be job postings. So, but it's probably most efficient to just like find me here during a break. All right, cool. Any other questions? Yeah. So, yeah, so I was going to make some joke, but I'm not that fast. I'm what's called the Chief Product Officer, which in our world just happens to mean all product management rolls up to me, all the engineering, product engineering rolls up to me through smart people that do great shit, directors and stuff like that. We're very flat, probably too flat. We have a team that does launch, implementation, product lifecycle stuff for our enterprise deals. And then there's some random other people that are in there. So basically, if it's technology and product stuff, it falls into the work that I do. But what I do today is like move shit out of other people's way. I'm still a mentor here at Capital Factory, have been for a bunch of years. I am by birth an engineer, but no one lets me near code that's in the critical path. You do not want my stuff to go onto trunk. That's a bad idea. Stuff will break and I will be busy meeting with people. So, other questions? Yeah, let me know if you're interested. Love to talk to you. Thanks.
Thank you.
All right.
Thanks, Simon. So if you have any more questions, stick around. Also for the little happy hour that we do afterwards downstairs at the parking validation. If you park downstairs at the Omni Hotel, please do not forget to ask me for it. I got a stack of parking validation stickies. So please, I'll make another announcement at the end, but please don't forget. Save you a lot of money. Speakers and sponsors. So we're always looking for speakers and sponsors. If you have an idea, you want to sponsor, please reach out to me in any of these three methods. Again, topics, right? I think speakers are a foundation to the React ATX meetup. Animations, React compilers, really cool stuff that people want to listen to and come out and hang out with. Here's a list of topics. Pick one. If you have no experience, don't worry about it. I can help you. Don't be afraid. Just come on out. Again, there's going to be a happy hour afterwards. Downstairs, we're going to take the elevator, and it's directly across the way right here at the Omni Hotel bar and dining area. So little house rules. We have to be out by 8 p.m. Hard. Like, we're done. So around 7:45, we'll call it quits. As you can see, you can look around. If there's any trash around you, please just help out, pick it up. Don't worry about moving the seats or anything like that. We can leave it as it is. But we do need to keep it tidy. Capital Factory is getting a little strict with the rules. And so I got to fill out some forms before we all leave. So if you can help me out, keep this place tidy and clean, we can get out of here and continue being sponsored by the Capital Factory. I really appreciate that. There's the restrooms. Come the same way you came in through that hallway. Men's rooms on the left, women's on the right. Right before you get to the security doors, there's the restrooms there. And again, there's food. I don't know if there's still food and drink. I don't know if there's still food, but there's drinks back there, so please help yourself. Without further ado, let's start off with the React compiler presentation. Unless there's any more questions or anything. We're good? All right, let's get going.
Is it okay? Good. Okay. Hello everyone. Thank you for joining me today to talk about React Compiler. Let me fix the fact that it's not full screen. Okay. Again, thank you for joining. We'll be talking about React Compiler. It's called Performance Wins and Losses, but the more I was doing this slideshow, the more I understood that we need to dive into some of the technical details to know what compiler is actually doing and why. Some of the metrics that we'll be looking at change like that, so bear with me. And let's get straight into it. So, who am I? I'm Mykyta. I also go by Nick. Why do you need to listen to me? 10 years of overall experience, and currently I'm engineering manager at Lean.js. Lean.js, we are the Austin local startup. We are doing supply chain management thingies. Quite boring. Will not bore you with the details of what we do, but we have a pretty solid team, and I'm kind of leading it at this point. Okay, so our talk will have 3 parts. One will be a mix of talking about what the hell compiler is, how it affects the performance of your app, how you can implement it, and what are some technical pitfalls that you might encounter. Key takeaways will take a couple of minutes, and at the end we will have some time for Q&A. Before I go on, if you have a question this very second, please formulate it as yes or no question so I can answer it quickly. If you have like a full question with full answer and / discussion, let's keep it till Q&A. Okay? Okay. So, why compiler is needed in the first place? Well, short answer is re-renders. We are battling re-renders. We kind of demonize them at this point, but the whole idea of the compiler is to make sure that your React app doesn't re-render excessively, and it helps you do in an automated way. And we'll get to the problem statement next. So yeah, very simple explanation, I know. Let's bear through it. We have a component. If we have a new data, component re-renders. If we have children in this component, the render goes down the chain. So now we have lagging animation. Yeah, so, and if we have a slow child component, it will be blocking our event loop. We don't want that. So what is the main way how we solve that is? Yes, memoization, exactly, thank you. So yes, memoization and its ramifications. So let's go quickly about what memoization is and what it solves. We'll start with React Memo. React Memo is our higher order component given to us by React developers to wrap our existing components to make sure that the parent changes don't trigger the re-render down the chain. The simple usage is we just wrap the component in React Memo, and that's it. It works perfectly fine if we have non-referential data coming as props into our components, aka strings and numbers. But if we have some data, objects, arrays, or functions, it will not help. So we have memo hooks. Memo hooks are our usual suspects are use memo and use callback. There are 2 of them, actually, that's all. And the simple use case would be if we have some data and then we have onChange, aka some function that we want to pass into component, we'll wrap the data into use memo and the function into use callback. Surprise, surprise, as a lot of stuff in React, use callback is kind of synthetic sugar. Not quite, but still. You can replace usage of use callback as use memo, and the result of the memoized function will return a function that you want to memoize, and it will keep its referential value, meaning that you technically don't need use callback. It's just a simpler way of doing stuff that React gave us, as with a lot of things, JSX included. So yeah, this is where we end up. I don't like this pattern. I haven't liked it in a while. Some people say it's hard to debug. In my opinion, it's just annoying. You have to remember to wrap everything in use memo and use callback. And if you miss one object, like your whole memoization chain is just done. Like your renders are back on, you have your INPs going into 3 digits, and you have no idea what the hell is happening with your performance, which is annoying. So yeah, that's the whole idea of compiler. It will relieve us from that painful investigation. What the hell are we missing, and why our components re-render? Hopefully. So what is compiler? Compiler is a tool, as I've said, that allows us to forget about writing memoization in React app via hooks and via wrapping into memo component. So this is the simple example. We have unmemoized component, and then we have everything memoized inside it, but compiler doesn't do it that way. You will never see compiler changing your JSX files. So let's dig a bit deeper into what the hell it actually does. So first of all, visual representation of what compiler does. It's just this belongs with that fire in the trash, which I'm really glad it is. Not quite, we'll talk about that. So what compiler does? Compiler does its best, honestly. First things first, it is compiler. I know that the difference between compiler and transpiler is arbitrary in this case, because it's not actually changing it into different language. It's not compiling to bytecode. Come again?
Still JavaScript, right?
Yes, yes.
Turning into bytecode, that's a compilation.
Exactly, yes, but it's still called compiler. Yes, thank you. On the left, you can see the JSX runtime. This is our transpiler and Babel, which usually transpiles our syntactic sugar of JSX into the JavaScript consumable code, and on the right, the result of the compiler. So the example is from compiler runtime, which Meta did a very cool thing called compiler playground. So you can check it out and see how your code would actually compile. And this is one of the examples. One thing to note, that compiler is more quote-unquote invasive to your code. So simple example is, if we'll take a look at the env variable. So we declare env variable in component in the top code snippet. If we'll look at the Babel, which is to the left, it keeps the variable and then passes variable into child component. On the other hand, compiler just knows you don't need this as a variable, so it will put it as a prop directly. It will not hurt your code, but I heard a couple of times that people are worried this is the case, but that's literally what compiler does. So you don't need to be worried about that. Plus, to be honest, people who develop compiler are way, way better than everyone here, no offense. So yeah, we are in a good hands. So simple examples of what compiler actually does. Let's take a look at the most common thing, where we have some data, which is an object, some onChange, which is a use callback function that should be wrapped in the use callback, and then we have child component, which actually consumes it. So the idea here is that it sees that onChange does not need to change, pun unintended actually. So it keeps it as a temporary variable outside of the component function. So next time component function will be called, the onChange will be referential, so it doesn't need to check if it's still there. But things change if we say that onChange we want to return the data. So now we're referencing the variable inside this component. So which, in our case, if we wanted to combat that, we would do something like onChange, use callback, and then we add a dependency array of data into this one. But compiler doesn't do that. The main idea of compiler, it actually throws away memoization and callback as an idea, and it does things a bit, well, it does memorize things. It's just not using the use mem and use callback anymore. We'll get to that a bit later. So the simple highlight is that it has two blocks, in this case T0 and T1. T0 resolves the memoization of the data, and T1 just resolves the render of the component. And on change that returns the data will reference the variable that is resolved as the result of T0. So T0 is our memo kind of thing. So yeah. Another a bit deeper example is how it, I already spoiled it a bit, but it dismantles useMemo as a whole. You will not see memoization functions and use callback functions as memoization in the React compiler result code, because it has its own way of doing things. And I will touch a bit in detail that later. Speaking hard varies sometimes. Same idea. If we want to pass the color and the color is dependent on the prop, we put it into useMemo, so it won't re-render child component, and this is what compiler does. So it knows that it has to figure out what to do with color as a T1 first. Then it remembers that onChange is also dependent on props, so it resolves it as a second, and then in T3 it just ties it up, essentially. So this is a small snippet from the stack trace that you can see when you either play with compiler on the playground that Meta did, or you just want to peek under the hood. What I was saying is previously is it actually actively goes forward and tries to remove memoization from your code. Like, it will not keep traces of useMemo function at all. It literally does things differently. So, and when you see this stack trace that says start memoize and finish memoize, it actually dismantled the useMemo usage that you had, and then went into its own loop, where logical loop, sorry, that it tries to memoize in its own way. So this is an example where it might get weird with compiler. So we have a state with memo component, and this is a component. It looks hideous. What it does, it has a use state that references the props, and then use memo sets new list. And then we have access to sorted list via just sorting on the sorted list. And then which we pass into our list. So the question to you would be, knowing that it tries to actively remove useMemo, what do you think compiler will do in this case?
It looks like an effect to me.
Come again?
Like the useMemo looks like an effect to me at this point, where you're actually probably could just get rid of it. List as a prop.
Okay. Yes, you can get rid of it. You should get rid of it. What will happen if you get rid of it? Just imagine that there is no useMemo function anymore.
I think it's going to not. I don't think it is going to get rid of it because there's potential breaking changes that it can have.
Exactly. Yes. Yes. It will try. It will see that useMemo, removing useMemo will get the component into infinite loop, because what will happen, it will be defining the state and then setting the state, defining the state, setting the state, and it will go into infinite render loop, and compiler will actively scream at you, do not do that. So to avoid that, you can do the use, you can have a directive no memo, which I forgot to put into the slides, but you can actively tell compiler to avoid problematic files. And compiler in general loves you when you follow the rules of React. So if you are trying to break them in such a weird way, it will intelligently skip problematic files altogether. It will just say, you do you, I do not care, I will not compile this component, this will go to JSX runtime, and that's it. So it will keep your old messy files. You do not need to worry about that. It will not optimize them, at least it won't hurt. So it's pretty good at it, and I think that's a huge win for using compiler in general. So with like the basic things established, let's look at the simple cases of the usage. Also, PSA, create React app is deprecated. I found it out yesterday, trying to do examples. So, you know, use create TS router app from 10stack. They're cool guys. I didn't heard about them like a month ago, but okay. so let's take a look at the simple example and how compiler will hold against it. So we have realistic usage of, we have some state via Redux or just use state. Then we have a button that just changes the state, and then we have alert that renders conditionally on the state, and then we have a very slow component. So usually what we would do is we would just wrap the very slow component into memo, and this would solve the problem. So getting back to the original code, do you think React compiler will handle it? Yes, it will. One thing to mention is, I should have mentioned earlier, sorry, that when you'll go to the Components tab in the React DevTools, you'll see not only memo, but memo with a sparkle. Memo with a sparkle means that compiler is actively trying to tell you that compiler did memorize this component itself. So you will have easier time debugging. Is it you? Is it compiler? You can blame compiler if you want to. So yes, exactly. It will just do one initial use effect in a slow component, and that's it. It will not re-render. So very good, very straightforward. Now same idea, but very slow component became a harder component. It has same stuff. Use memo, use callback. So we are solving it in a simple way. Well, in most common way, we would solve that by just wrapping it into memo, the component itself, using use memo and using use callback, the unholy trinity of React. Personally hate this style of writing code, but this is what we have to do. So going back to the original code, it should handle it. Yes, it does handle it. I literally took the same GIF because it does the same thing. So let's get to a bit more complicated example. Let's get to a component that has children. So now, what would you do to make sure that this doesn't re-render?
Use the React compiler.
Sure. Let's imagine you don't have React compiler. Let's imagine we're in the wrong timeline. So what would you do?
Run the function in the use callback.
Which function?
The handle button click.
You don't need to. Let's focus on the very slow component and another component inside it. Okay, we'll skip a bit. So yeah, you would try to wrap them in memo, both the child and the parent, which seems obvious, but can you spot the problem with this code? Like why it will not work?
Because another component, MO, because the reference to children is still changing, right?
Exactly, yes. So that code is literally the same as writing it as children prop, and when we pass another component as children, it can be shown like this. We're essentially passing a new object, and as Ryan said, yes, it will be a new object every time. So no differential equality. So what we have to do is we have to now do slow component children, which we do use memo, which is a weird thing, but this is the actual way we would circumvent that, which sounds awful. So going back to the original code, you can leave things like that, and do you think React compiler will fix it? Do you think it will know what to do?
I hope so.
Yes, yes, it will absolutely do. And yes, this is the third time I reuse the same GIF because it just does it. So with that out of the way, we took a look at the more simple examples, and now let's get into the number crunching. So number crunching, this is the part where we go deeper into performance. We found that compiler is very good at solving most common cases and even some of the convoluted cases. Now let's see what do we have as a trade-off, because there is always a trade-off. So before we start PSA, I was trying to find some React clones of the other apps because I don't have enough time to write like 7, 8, 10 example apps, which felt like actually digging up some fossils from 2016. Okay, so what are the measurements? So we are mostly interested in UI performance. We will measure it with Lighthouse, average of 5. I did development mode just because I was pressed for time. If I would have a bit more time, I would probably do production mode, because just building stuff is long. And I decided to use mobile mode just because it has slower CPU, which means that the difference between compiled and uncompiled version will be more visible. That's it. So what exactly are we measuring from Lighthouse? We will measure the largest content paid on load, total blocking time on load. We will do the interactive next paint on interactions. Interactions meaning that we'll do something that we think will trigger the re-render of the page. Well, the higher up the page, the better. And same for total blocking time for interactions, because we don't want to block our event loop. Bundling, I tried to compare Vite, I always don't know how to pronounce it correctly, versus Webpack, but I couldn't find any significant difference. Vite is just better by default, it's faster, so use Vite. I'm saying as the guy who uses Webpack all the time. And we'll try to see build time difference between compiled and non-compiled code, because compiler will take time to wrap up the code, which can increase build times, and we don't want our pipeline to be stuck for a long time. So,
question on bundling.
Yeah.
Because it's just a Babel plugin right now, right?
Yes.
So have they released like timelines for when like SWC or will implement an equivalent?
Come again?
It's like Vite's built with what, ESBuild or by default? ESBuild? Yeah, so like if you are using Vite and you just do like create Vite app or whatever,
Yes.
like, oh, I'm gonna add a compiler, now you have to add Babel.
Yes. Same for Webpack. It's the same, yes.
Right, but like, shouldn't they, but you don't know if they like said that they're gonna release like a
So far it's in beta, and all we know is that they use it in production for Instagram and Meta apps, but when they will release it, they don't know. The overall rumor was that they would do it with React 19, like bundle them together, and many people still think that React 19 is compiler, but it's not. I don't know the timeline, and unfortunately I do not have insider friends in Meta, so if you do, please tell me. Okay, so let's get to the numbers. Exhibit A, a simple app, 4,500 lines of code. It was initially React 16, so I did upgrade it. What is this app? This app is a clone of famous video platform, starting with U, ending with B. You can get the rest. So let's take a look at the largest content paint. Virtual difference. So as you can see, I tried to put error bars. So you would see if the error bar is too high, it means that it's not as strict in terms of results. So results are all over the place, but you can estimate the average. As you can see, no substantial difference. To be fair, React 19 compiler, as we'll see later, has more impact if you, well, actually do things React way. So total blocking time, again, nothing drastic. One thing that I was surprised by is that it did increase with compiler, but then I remembered that it, well, memoizes everything. Well, memoizes, let's keep it in quotes. So it does make sense that on initial load, your total blocking time would be more, because what it does, it like spins the wheel to memorize every component. So then on the interactions, it will get worse. I don't know why, don't ask me. I literally ran the number twice on this specific app and it got worse. So the lesson from this is, I don't know. I just don't know. It's still in beta. That's the lesson. But jokes aside, it is showing it. Why in this specific case the numbers are bigger? Because this is a quote-unquote YouTube clone, which means that to have some interaction that would touch the whole page, I had to navigate somewhere. Like I click the video, I navigate, I click to library, I navigate, I click to liked. I navigate. So this is the route change, and route change is again like you're hitting the whole page, which again increases your time to memorize everything. So it just reiterates the load at this point. And same with total blocking time. So for this app specifically, keep in mind that if your app has a lot of routes and you change them frequently, would be interesting case for React Native, but you will probably see the same results as you have on load. And build time is not significant change. For this case, I opted to do only React 19 for build time. I didn't want to pollute the graph, and I don't think there will be a big difference. As already mentioned, it's just a Babel plugin, so we are interested in how much longer the build will take compared between no compiler and compiler. So as you can see, the error bar is pretty small, and the build time is in seconds. It's a small app, and the bump is like less than 5%, which is pretty good, in my opinion, for getting rid of any memorization in your app. So Exhibit B, 3,000 lines of code. This is another small app, but this one is, I understood the error of my ways by choosing the app that has a lot of route changes. So let's stick to something that is actual single page application and has a lot of moving parts on the page itself, and not so much route changes. So largest content paint, no changes, virtually none. It's a small app. That's expected, but with total blocking time on the load, it's a bit bigger, but now the change is not as drastic, and as you can see, the error bar, the candle part is bigger, which means that the variability might have played into this, but I would still take it as a win, like getting huge quality of life, but increasing your total blocking time by only seemingly 20% is a very good thing, unless you're doing e-commerce and Next.js, which we'll get to a bit later. So if you are doing the client-side application, I would take that as a huge win for the bigger code base. Yeah, so, and as expected, when you do interactions, everything is memoized, so you don't spin the wheels so much. You don't bother your CPU because everything is memoized. Though, as you can see, the INP is a very small number, and even for milliseconds, so the error bar is pretty high. Sorry, it's pretty big, which means that results might be a little bit all over the place, but it's literally mirroring version 18, version 19. And no changes in total blocking time. This one is a surprise for me personally, but the more I think about it, the more I understand that it's probably not 0. That's why it's consistently 10. And app doesn't have enough things going on to make it pop up. Okay, and build time, again, it's a very small app. It had no difference, and if they don't, but total blocking time on load don't. But total blocking time on load did get smaller in case of our app, and I feel that's more an anomaly. But what I was able to find, that the page that I was testing it on had a very heavy table with lots of stuff going on, like drag and drop. Imagine AG grid, but even worse in terms of functionality, which is surprising. Same thing, compiler was very, very helpful when getting to interactions. So if you know that your users have a long time spending on route / on the page, I feel compiler just does everything pretty well. Same goes for total blocking time. With compiler, we can see a very, very substantial decrease when you're trying to interact with the app, which is, in my opinion, pretty good. And while going over this use case, I found that we have a fallback prop with object, and going back to the point that you might miss one object in your memo chain and your whole memo chain breaks, this was the case. We had one developer just leave a fallback as empty object for the past prop, and it was just breaking referential equality every time. This just solved it like this, which is pretty great. Build time got decreased a bit. I don't know why. I feel this is the thing of me just messing with it constantly. So I would take this result with the pinch of salt, grain of salt. Don't trust this literally. And then Exhibit D, I just came up with a very small app for Next.js. Next.js 15 does allow you to turn on the compiler, so I wanted to see what's that about. Disclaimer, I haven't worked with Next.js properly since version 11, so I tried my best to do somewhat realistic page, like it's literally one page, but still, some of the results, since it's a very small page, large content paint, the same, total blocking time, surprisingly the same. I wasn't expecting that. I didn't do any memoization on the components, so this one baffles me. It's at 30 milliseconds for literally every test I did across all of the testing samples. It's hard for me to draw conclusions for this one. But again, on interactions, our Next Paint is quicker, like almost 2.5 times quicker, which is a huge win in my eyes. Again, I didn't do anything. For Next.js, it was purely new project, new React, no memoization done. I didn't even think about that, and those are the results, which in my eyes are pretty awesome. And same for total blocking time, like compiler just keeps on winning. And then build time was negligible because app is very small, and I feel that in this case it's just the difference in time. So it's not that compiler actually helped building faster, because again, it's bubble plugin, so it's another plugin that it has to go through. So key takeaways. First of all, compiler is not part of React 19. This is a separate thing that currently you have to install as a bubble plugin. Compiler should be used with version 19. React team reiterates that every time. It can be viable with version 18. I tried it on our code base and it did work. So if you want to use React compiler, be sure to religiously follow rules of React. This will help you because, for example, in my working app, it just skipped like 30% of components. So the results would be even more drastic if it wouldn't. You do not need to move your code base away from memos, just because, as mentioned earlier, it does actively remove use memos from your code base when it compiles. So if it can, it will do that. If it won't, it will just tell you on the build that, look, out of 130 components, I skipped 25. And you can dig into that later. And if you think that we are in the new era of writing React, unfortunately, you would be wrong, because compiler can't catch all unnecessary renders. At the end of the day, we are here to do that work, but it definitely removes a lot of boilerplate code. So I feel that yes, compiler is good enough for majority of the cases. It does help. The only problem moving forward with compiler, if you want to squeeze every ounce of performance from your app, you will now need to know both how compiler works and where to use memo to get the best performance out of your app. And for 3.5 endures of MobX, yeah, it doesn't work. Compiler doesn't work with MobX because MobX wraps components into observable, which is a completely different story. So if you want to use it with MobX, chances are you won't. On the other hand, MobX is a completely different beast, so I don't think that compiler would help it out as much as you would expect. That is pretty much it. Thank you for your time, thank you for your attention, thank you for your participation in the questions, and let's get to Q&A time.
Questions? Shout them out.
Yeah.
Did you compare any benchmarks to like Million.js or anything like that?
No, I haven't. The focus of the slides was completely on the compiler. Like, I'm doing the discovery for my work project anyway, so why not? But the main focus was on the React compiler and not. Okay. callback. Does React have a code mod that would repeat the ones that are no longer necessary for the import? That would be really helpful. Correct, that build mod, but maybe you could remove the use memos from your source code and just kind of compile them and then establish the list.
That may be, so they have the linter this in there. I started using it lately. So maybe that'll come in the linter. We'll tell you like, hey, this is unnecessary. Maybe.
There is no linter for that.
Yes. There is a React compiler linter right now.
Yes, but it doesn't shout at you. It shouts at you only when you break the compiler.
Yeah.
But it doesn't say stop using this memo. It's like it's chill about that for now. Maybe. I don't think this will be the case, to be honest, just because we'll still need some edge cases where we have to manually memorize stuff. Because as good as compiler looks, it will, if it catches only 9 out of 10 cases, we still need to do the 10 case ourselves. So I don't expect this to be the case, but maybe. I don't have to think about it.
It sounds like it's very concerned about referential equality in passing that line component. What happens if you're using these memos just for like a conversation with a static function? So you're not passing like let's strip that component and repeat that alone.
By default, it tries to remove use memo as a concept. Like, unless the compiler detects that it won't be able to compile your component, then it will leave it alone. Outside of that, again, it just has a different approach to memorization. It's like compile time memorization. So it will memorize, just not to the function. Yes, there is a directive same as use strict or use client or use server. There is a no memo directive which you can use at the top of the file or at the start of the function. You don't want to memorize the function. So you can call that on the case. So what was class? That would be a very good thing. I have nothing to say. I'm not using it. That's very good. Still alive, error boundaries. We still have error boundaries,
Yeah.
so yeah, I will definitely. Okay, that's a wrap. Thank you, everyone.
Our next presentation is on CSS animation by Mario.
Hello, can everyone hear me? All right, just one moment. Get everything ready. Okay, everyone in the back can hear me? Everything good? Okay, hello, my name is Mario Jimenez, and I'm going to do a presentation about CSS and JavaScript animations in React. So just a little bit about the presentation is going to be just really brief history about animations and websites and in the web, brief intro on Java, on CSS and JavaScript, why animations inside website can help your metrics, your sales, and so on, how to integrate some CSS animations and JavaScript libraries, just really quick, and just the other thing is going to talk about is great examples. For one particular animation framework, I am going to just show a website that just has a lot of examples, and it's something that you can install through NPM and you can just start right away making those type of animations. So it's just like a really short guide. It's not something too comprehensive, so it's just a starter animation. So a little bit about me. I'm just a former software engineer and social media pro in a startup. Currently pursuing a master's degree in computer science. Currently volunteering for Austin Public Library. We're just making a product that we're shipping really soon after they review how everything's going. Sometimes I build some software as a service, companies, some online businesses, and blog, and sometimes make music and photography. Okay, so brief animation about web animations in websites. I think the best example would be for GIF format files. I'm not sure if you remember these. The reason they got started is just to make websites for companies more interactive, like maybe for IBM and for Nintendo. Basically, they would just like put them in websites and just to bring more users in. So after that happened in the 1980s, in the 90s, things started getting more traction with AOL. Just more people started getting online. It wasn't just people in universities or in military groups. So after that, the main animation tool is going to be Adobe Flash. I'm not sure if anyone remembers that. And it was really popular. Like almost every company on planet Earth was using it. Nokia was using it, for example. But unfortunately, it was really insecure, so that's why people just stopped using it. And right now, what most people are using for animations is JavaScript library, JavaScript, HTML5, Canvas, and CSS, with JavaScript just being the most popular thing. For CSS, it was developed by Hakum Hyun Lee. He's one of the main developers of the Opera browser. Then he just suggested that while he was getting his PhD. And JavaScript was just made by Brendan Ike when the Netscape wars were going on in the website and the internet. I'm not sure if anyone remembers that. And the latest example, the latest addition to animations on websites is HTML5. So the main takeaway that I want to tell you about is that you can use all three. You can use a Canvas tool, you can use CSS, you can use JavaScript, you can just use CSS and JavaScript, or you can just use JavaScript or just CSS. It just depends on what project you want and what the preference is. Okay, so you can do pretty much anything you can just set your mind to for in animations. You can make interactive menus, video games, data science projects for the local government, help guides, short films, just anything. Maybe you're trying to sell a product, maybe you're trying to sell a camera, maybe you're trying to sell a car, maybe you're trying to do an art history exhibit for anybody. You can do just pretty much anything you want. So why is animations good for your React app? It just makes it more interactive and more fun for the non-technical users. They may be people who not really software engineers, they don't really understand what's going on, but they just enjoy going to websites and just using it. And after that, the other thing I wanted to say is that sometimes people just remember cool interactions. Like maybe you're going to, maybe for Apple, maybe you're trying to go for a Dell website and you see a really cool animation. Sometimes people remember that really particular thing, and then sometimes they tell their friends. So it's more word of mouth for sales. It also just directs people to what exactly you want to see. So if you're trying to sell a computer, you're trying to sell software, you can just show it to people and just be more expressive with it. It increases click-through rates and just leads to more sales. So that's pretty much my main focus. It just makes people just want to come more to your website, and sometimes also increases more sales. So. Okay, and so it's really easy to integrate animations to websites. You can start literally right away. You can add your own custom code snippets, just trying to say, maybe change some things in the text, maybe change something in the menu, and so on. Maybe you can add an external library, maybe you can put inline code, or you can do animation frameworks. And you can just go to NPM and just type anything that you think of, and then usually there's an animation library for that. So there are actually some cons for animations, and if there's too many animations, too many things going on, just too much visual noise for a person or for a user, and that just honestly is a turn off. Some people just don't like too many things at the same time, and you usually have like maybe a minute to get a client to just stay in your web page, and if they see even like one thing wrong, they just like don't use it again. So just something to bear in mind. And if it's just too much content, like too many animations, too many JavaScript code, and the app gets sluggish. And also like bad, just poorly done animation, that also turns people off. And one thing that's very important for just depending on the JavaScript library you're using, what project you're using, it may not work on a browser, something to keep in mind. So for Chrome with WebGL animations, that doesn't show up. And for CSS animations, sometimes in Safari it doesn't show up well. So just want something to keep in mind. Okay, so right now I'm just going to show some examples, some animation libraries that are just all in NPM and you can install in React right away. So I'm going to just show it. This is just an animate on scroll library. So basically, you just install a few snippets of JavaScript code, and you just add like a data source to whatever you want, and then it just shows like right there. You don't have to really do anything. You just add this little snippet of code, and then it just like automatically adds animations. So maybe you want to do a flip animation. Maybe you want to do zoom animation. Depends on what you want, but it's readily available. Okay, another animation library that you can try. Maybe you just want more interactive content. There's another animation library called animate.css. So again, it's just like a few little snippets of code, just class name, and just add whatever you want, and then you can make content pop up. You can make it bounce up. You can make it fade in. You can make it fade out. You can make it flip it. You can add a hinge. It's basically anything that you want, you can add it. Another
Is that one pure CSS on JavaScript?
Which one?
This one here? Is it just pure CSS?
I believe so. Here's an installation. I think you do need to just add a lot, just like a small snippet of like CSS library, but that's it. I think there's other examples out there, but it's an example that you can just add like a little line of code and you can do pretty much anything you want. Another animation library that's again available for React is gradient.js. Basically, just adds this like really cool looking gradation to anything that you want, and you can change it. Maybe you don't want it left or right, you want it diagonal, so it changes it right away. Maybe you want a radial animation, it also changes it, like the color just pops in. Maybe you want to add your custom code, and that's also readily available. And for just changing anything up, the only thing that changes is here, and just one little snippet of code. And then you can just add anything you want. Another JavaScript animation library is going to be fullpage.js. Maybe you've seen these marketing pages, or they're trying to sell you something from like a computer, whatever, and you're wondering like how didn't they get it like to work so accurately, maybe on mobile devices, Android? Well, this is one library that you can use. You click down, and then it just goes like automatically, and it just stays like right there in the center. And it works on Android devices, tablets, on anything that you want. And again, all of this is available on JavaScript, so you can just use it whenever you want. Another library that's really good that you can try is dtree.js library. Maybe you want to do a data science project. Maybe you work for maybe the finance section of your company. Maybe you work for a local government. Maybe you work for a nonprofit. Well, this is readily available. It's another JavaScript library that you can put for React, and again, it's free. You can just do anything you want. Maybe you want to do zoomable click parking. You want to just show like data content. Well, that's all, again, really easy to make. Maybe you want something that shows content about the US. It shows it right there. You can add anything you want there. Maybe you want to add a shard, like sequence, just to show like what's selling, what isn't selling, what's the problem with the department. It shows it like right there. Then it's really easy to edit, really easy to like change, really customizable. Whatever you want to make, you can make it. Okay, another, maybe you want to add like a heat map to whatever happened. Maybe there's a local fire and you want to show data on that. That's also available. And again, that's all on npm, so you can just click on this npmi.d3 to make sales. First example is the Apple library, the Apple website. You can see that, and this seems like a little bit like really hard to, like really out there, really hard to make, but no, this is just JavaScript and CSS. It's not really anything hard. They just have a dedicated team to just focus on making it look good, but anyone here can make something like this even better, so that's what I'm trying to say. You can also look for the MacBook section of Apple. It's the same thing, it's just JavaScript and CSS. And usually, if a person is just looking at this, they're thinking, oh, this is so cool. And they just, that's how you get sales. That's how people just like, you attract people to your company, your website, software, whatever. So maybe you're trying, another example, maybe you're trying to do an art exhibit for anything. Here's another thing that's available. It's one of my personal favorites is an Andy Warhol, like museum like exhibit. It just shows like everything just related to him, all his artwork, all his history. And again, this is just like JavaScript and CSS. So. And another example is going to be for video games that you can make. You can also make just games inside your mobile browser. Maybe you want to make something with JavaScript and CSS that's similar to this, then you can make it. And this is a working website, by the way, so I'm not sure if anyone wants to do this. Like, there's a trolley with 5 people. You can pull the lever, and the other track that kills 1 person. What do you want the guys to do? Pull the lever? Okay. There you go. And this is just JavaScript. Like, you can just do this anytime. You can do this if you want to. You can even make it better. So the other thing is maybe you're trying to do like an art exhibit, or maybe you're trying to do a presentation about anything. This is also, again, JavaScript. So you can see everything that seems like really hard to do, but it's really simple. See, what you're doing here is, again, a fade in. It's just basically, this is just simple like static content, and they just add a fade in, like the animation library that I showed earlier. So I guess the last thing I'm going to show is a really good library that you can use. It's called d3.js. It's another JavaScript and React library. Basically, you can do just incredible things with that. And all of this is just JavaScript. Maybe you work for a camera company like Canon, and you're trying to just show a product. Then you can use this library, and you can just show something like really high definition, just either for the meeting, you're trying to sell something you can try. Another one I wanted to try is maybe you're trying to do a nonprofit for just going green, for trying to like more like an ecological project. So this is another example. So you're gonna see all this like extremely like really high effort things. And you're thinking to yourself, you could never do that, but yeah, you can. This is just one library, what one library is capable of. So. And the other one I wanted to show you is, maybe you also want to make a portfolio website using this animation library. You can also do that. Maybe you're trying to also sell a car. Maybe you just want to show like a product. Maybe you're working in product design, you want to show a car and how it works. This is also done in JavaScript. Basically just a running car that you can just change to show whatever you want. You show it however you want. Maybe you want investors to just look at your product that you're theorizing, that you're trying to work on. You can just use this software. So that's it. Okay, those were some examples of the libraries, and just as you can try using, and you can try just making on your own. So the last thing I wanted to tell. Let's see, another thing I wanted to say, I'm going to just tell Roberto about the presentation so anyone can download it and look at the links. So I guess the conclusion is that animations can make your site look much better, but it can turn people away if you don't really do it well. So just suggestion, just if you're trying to add something new, maybe just using the moderation, just you do A/B testing, just see what clients like, what clients don't like, what people like, what users want, before you do anything. And just test your code before shipping. Again, some animation works on some libraries, but on some browsers, but it doesn't work on other browsers, so just bear that in mind. And I guess don't be intimidated by doing anything. Maybe just start small, and then just show it to maybe your friends or a user group, and then just see how that takes you. And the last thing is you can do any of the projects I showed you. I'm gonna tell Roberto to upload that PowerPoint to maybe the Meetup group or wherever, just so anyone has access here and they can just make any like awesome or incredible thing they want, okay? So that's it. Here's my GitHub and my social media account if anyone wants to follow me. I don't know. I guess that's it. The only thing I wanted to ask is any questions, anything that you want to ask. I'll do my best to help to just answer it. Yeah.
Questions, comments?
Yeah.
I just have a comment. I guess I was playing around 3JS before also, like last year. And I found there's something called React Fiber, which is React and 3JS. So 3JS is like kind of just using, it's like a JavaScript library.
Yeah.
React Fiber, you can actually have like each of those 3D models as components. And you can like build a React project with those 3D models.
Yeah, that sounds pretty cool. Maybe you can tell Roberto and we can put it in the Meetup group so you have like more content.
Yeah, yeah.
All right.
And then the other one that I guess I'm building like my portfolio side, and one thing I came across was like using like animated SVGs. So it's just like an SVG and then just like CSS to animate it. And I don't think there's any JavaScript or anything, so it's like super lightweight. But one thing that's like cool that you can do is you can build like a self-drawing SVG.
Yeah.
So like especially if it's like a one line like image, like you see like this one line faces, that'll self-draw, and you can do it on scroll and like just repeatedly.
Yeah, sounds cool. The thing for SVGs is that you can like take the browser like far away or close it up, and it's always like looks pristine. Like yeah.
There's like a lot more flexibility with it. It's super lightweight.
Yeah, it's pretty good. I didn't include it. It's a little, but it's a starter presentation. But maybe in the other presentation. Thank you.
Yeah, just
Thank you.
What would be your rule of thumb between choosing the CSS-based animation library versus JavaScript-based library?
Yes, it just depends on the project, on like, what the people want, and what like how much bandwidth do we have. Like, can we add this CSS library or JavaScript library to this particular thing, and how much time do we have? How does it look good, or does it look bad on browser, and so on?
Would that affect performance and SEO?
Maybe a few seconds, but most of these libraries are very, very lightweight, like maybe like less than a megabyte, a few kilobytes. So I don't think you should be having any problems. Just like I said, just test it out first and then just move on before shipping. Okay? Yeah.
Do you have a link to the library, the CSS you shared?
Which one?
You know where you were clicking to get to the.
Yeah, I'll post the slides on the Meetup chat.
And okay, yeah, he'll post it. You want me to just tell him?
Yeah, sure.
Which one is it? This one?
There was a page where there was a lot of them, and then you would like click.
Oh, that's tree.js.
What is it?
Tree.js. You spell tree and then JS. And that's
Big S.
tree. The number 3 is spelled out and then JS.
Talking about what page? 3.js.
I think is it animate.css is the one with the text thing.
Yeah. Yeah.
Can you correct me if I'm wrong? I thought D3.js is a chart library. Is it also like responsible for animations as well?
I just used it for like data science projects. Like if you're in a local government nonprofit and you want to show like data like really like really simple and really like easy to digest, that's what I used it for. But that, yeah.
It's a chart library that uses animation.
Yeah, it's just for like data science projects. I think Python also has I think so, a library, but I don't really remember right now. You in the back, Miss?
Yeah, I think there's 3JS and there's 3D or
D3.
3JS. So those are two different things.
Yeah.
Which one?
So there's D3JS
Right.
and then there's 3.js, and those are two different things.
Okay.
So that's slightly confusing.
Okay.
Yeah, it is.
Great naming conventions.
Yeah.
As developers,
Okay.
Have you looked into JS AP as well?
Yeah.
JavaScript.
Yeah, if you wanna.
Oh, have you looked into JS AP?
Yeah.
JS AP as well. I think it's similar to Readside to JavaScript animations.
DSP?
GSAP.
DSAP. No, I haven't looked at it. I'll look at it.
Yeah, I haven't played around with it, but it's something that I want to look at as well.
Okay, you can tell Roberto, and then we'll just share everything to you. Thank you.
Does the rule of animation depends upon the business domain?
Do you have the microphone? Yeah. Sorry, man. I was just taking you around.
So
yeah.
the level of animation that we create, does it depends upon the business domain?
Like you're saying, like the domain, like maybe AOL.com, and you're, like maybe you're trying to make like the domain name. Is this? Are you saying?
I mean the business application, yeah, like
the industry.
Like e-commerce versus like.
Yeah.
It just depends on, again, it just depends on your users, and it just depends on what they're expecting. Maybe if you sell something like too over the top for somebody like buying shoes, it's not, they're not gonna
Why
like
do
it.
somebody choose animations versus not choose implementing animations?
It just depends, again, it just depends on your market. It just depends on who's buying.
Yeah.
Yeah, why do you not that is so good.
So you're afraid you don't have enough time or money, or you can't worry about that right now. It's extraneous stuff.
Again, just depends. That answer your question? Or?
Yeah.
Okay, thank you, man.
yeah, but you can sell more stuff. Like one that I just did for a proposal, they're using 3D product configurator. It's literally what it's called. It's a library that's open source, and they want to see a toolbox, and like people change the color on there, and their competitors now doing it, and now they want to do it.
Yeah.
The competitors not selling them, and so they come to me and just like, can you do this? And
Yeah. That happens a lot. You'll be in business forever because it's just like everyone's competing against each other.
yeah, and that's literally what this stuff is. Is like if the competitor, you can just click and get a, your exact toolbox or your exact shoe, and then it swirls around. You're gonna buy from one of those and not the other.
Yeah. Okay. Yeah. Thank you, both of you. Anybody else? Or? Okay. Yeah.
I'll be quick. I'm just going to do a quick show and tell of a project I've been working on automating Next.js APIs. How many of you guys right now at your companies or yourself personally are paying for mocking servers? Anyone using mocking servers for their backend APIs? Yeah. What are you using?
We're just using Postman.
Postman. So you guys have a kind of bill with them to like exchange cash for a mocking server type of thing, or is it like on your free tier? Okay. Do you guys use Next.js for Cell by any chance? Because there's a little secret in Next.js that if you're a backend team developers or whatever, right, you don't need to use their templates, page templates, layout templates. all you have to use is their /API directory to create all your backend APIs. Let's see. And you can deploy those APIs to have your own mocking server. And Vercel is very generous, so you can have as many APIs as you want. Every single API in, oh wait, this is not showing the right window. Damn it. Okay. Just gotta mirror it. So the way that Next.js /Vercel work is that everything under the API directory, right? The key file name is route.ts, and inside your route.ts, you get your get, you put your methods in there, right? We all know that pattern when we create our APIs for our front end. And I recommend for your APIs, especially if you don't pay for mocking services, because obviously the free tier is very generous on Vercel, and on top of that, every API gets its own function, right? Every get method, every launch the fluid serverless full system. And so why I'm saying that is that if you just build APIs with Vercel, you can get really, really far. So one of the projects I've been working on, and I wanted to use Next.js, is like a little plugin. But here's the idea. The idea here is, as a consultant, you see this all the time, right? Maybe as developers too, throughout your experiences, you'll see this problem over and over again. I have a data source. I got to set up a service in front of it to feed it to my clients. And those clients could be other internal tools. It can be mobile development platforms. It can also be third party, or it can be my web page, right? Whatever the case is, someone has to go in there and figure out, okay, I want to use a server. I want to use maybe a Go, maybe a Rust, use TypeScript, whatever the new hot thing is. If you're a company, there's this bike shed moment before you decide what server you want to use. And then once you figure out, okay, we're going to use Express.js, okay, what version, what validation library, okay, what kind of database driver we're going to be using with this. Is it going to be rate limiting? Are we going to use our own auth, right? After you bike shed over that, now the developers can come in and start cracking, getting ready, writing code. And then on top of that, there's very small nuances, right? Okay, what libraries are going to be using, and this, and that, and so on and so forth. And are we going to use 100% TypeScript or not use TypeScript? And then on top of that, right, the front-end team is still waiting for their APIs so they can get cracking. And usually to solve that problem, when you have this back-end divide with the front-end, is like, oh, you know what? Let's just have GraphQL. You know, screw this. We'll just write our queries, whatever the case is, because I can't stand, right, the red tape, so on and so forth. And so part of the project I'm working on is I want to make writing APIs super cheap, within seconds. And I thought Next.js would be a great intro to that because it's free, and they just came out with fluid serverless, whatever infrastructure. But the idea here is, like, if we write APIs all the time, isn't there a standard already? Yes, it's called Open API Spec. But it's really hard to, I guess nowadays it's not because you have AI, but prior to that, it's very hard to write it, to maintain it, to a lot of nuances. Is it version 3.0, 3.1? There's Postman now, and so it kind of like puts in a bind, like, okay, as a developer, do I really want to use Open API for my stuff? No, right? But I'm going to borrow an idea from like DevOps world, where they have this declarative configuration. Basically, you write a configuration and you feed into a machine, and the machine promises you that whatever you wrote in that configuration, it will build, it will honor it, and it will fulfill it, right? Promise theory, if you're into that. And so in the same spirit as a, I guess, full stack developer and running into this problem over and over again and hating writing Node.js servers over and over again with Happy, Express, Koa, nowadays Fastify, right? It just gets repetitive, and it's the same thing. I'm still writing GET requests, I'm still writing API, I'm still writing POST requests, I'm still creating a body, I have to validate this, I gotta do that and do that. And so the idea here is like, okay, let's just start out with a declarative configuration. Now, bear with me on the naming. I call it API route definition, right? It's not, just bear with it, right? So you have this API, the idea is that you have this API route definition. And it's very similar to, it's definitely JSON schema, but it's very similar to Open API spec. So if you're already using Open API spec, this is very familiar with you. The schema and a lot of these words are going to flow right into this. But the idea here is like, hey, you just define this configuration. Right now it's on JSON, but if you're into YAML, you can write it in YAML, what have you. Part of the writing an API, though, and especially when you have this API backend divide, right, is like, okay, we don't know what the schema is, right? We don't know what the contract is because the database hasn't been set up. So we're just going to mock it, right? Or we can even mock it because the infrastructure team who's going to set up their node server or whatever is not even ready yet, right? So now as a front-end developer, I'm just going to write like a fixture or something so that when I click on this button, it's going to imitate a request call and so on and so forth. So what I went through my examples, and I kind of figured out, okay, for the most time, you want a response mode. When you're creating an API and you have no idea what the heck it is, the response mode is echo, right? You just want to know like the server's out there and it's working. And at least I know the path. In this case, the path is API, pets, pet ID. And it's API/API because you are on Next.js, right? That's going to be the default path. So when you fill out this configuration and you give it bare minimum, right? The command that I've been working on that you write is called a route controller. I'm not setting the names, so just bear with me with the names. So it will be an npm package where you just write route controller, apply the route definition. And you run that, and it's going to do a bunch of checks and everything. There's a validation error here. But once it passes the validation checks, what's the error here? Oh, parameters. I think that's why I had it here. Again, you can use AI to create these specs for you if you don't want to memorize them. Right, so here's this one. Here's a better example of how like sophisticated this thing can get. The point is, you're not going to write code, right? You just want the machine to honor the configuration, what I want the API to do. I want to describe it. And so given this path, given a GET request, I'm going to change the response modes to echo, right? I'm going to just run it. And what happens in the background is that it's going to, you're on Next.js, so it's going to follow the Next.js, the rules of creating APIs, right? So the path, right, has the dynamic parameter pet ID, right, in brackets. It's going to generate the route.ts file for you. In this case, it's a GET request, so I explicitly create a folder called GET. Inside that GET request is the definition you just created, and the index.ts is the code that is generated to run that. And once you run it and you build it, it is live and working almost like just immediately, right? You don't write any code, you just write that spec and it's echoing back, right? Now, if this is, because I'm working on Next.js project, imagine the next thing is build, push it to GitHub, use the Vercel Git, whatever, and then within like a minute, you already have a deployed mocking server free online, right? So it doesn't break your developer flow whatsoever. It's just kind of like a managed API mocking server. For right now, it's mocking. Or actually, right now, it's echoing. But if we switch over to a mocking service, so mock, now you specify, hey, I have a mock, meaning the back-end team and the front-end team, we figured out a contract. We come to the responses. It's going to be a 200 response because, coming from the database, MongoDB, Postgres, SQL Server, whatever. And this is what it's going to look like. It's a JSON package with these properties associated with it: ID, name, and type. Cool. The back-end team signs off on it. The front-end team says, great. The back-end team, whoever's working on this Next.js API, runs the command, generates the code that will honor that contract, and you're off to races again, right? So now, when you refresh the page, you hit the API, it's coming back with that mock data, right? So now your front-end team is up and running. Again, npm or git commit, git push, let Vercel build and deploy your APIs, right? And then if you just take this for a second, for a spin, and you think about it some more, what else can you automate without touching any code? Again, you're not touching any code. This is just declarative-driven API building. I don't know what words to use here, but if you think about it, we all also bike shit over ORMs. Should we use an ORM? Should we use a query builder? Let's do this, let's do that. Should the application be the migration handler of a database, right? We all have these philosophies of like, where the boundary between an app responsibilities versus like the actual data source responsibilities. And of course, a lot of developers don't know SQL, they don't know anything about databases, and so the vast majority of knowledge is like, oh, we're just going to use an ORM. What I'm saying is, with ORMs becomes developer human error, because someone has to code it, someone has to write it, and the more hands that are on code, the more error prone you are. What this does is like you define a query using the same JSON schema. There's certain keys here, right? The query, you're going to attach it to your API. Again, you're not writing any code. You're not going to use an ORM. You're not going to map the JavaScript, or you're not going to write JavaScript to map the data payload coming from the database, or nesting databases. You're not going to do any of that stuff, right? You're just going to tell the machine, like, look, I have a query, and I want to attach it to this API. Here's the schema, honor it, right? Before you do that, there's a couple questions you got to ask yourself, and kind of things you can do with it, right? Is that if you do this, what kind of parameters can I pass into the query? If I post request, right, with a body and I need to insert it, I need to be able to pass that request body into the query. And that's where these parameters comes into play, right? You can tell the query, like, look, I'm going to write a query, and I'm going to pass these parameters into it. So when you build it, make sure that you pass the parameters into the query. The output. From the database, this is the output that I expect. I'm going to write a query, and this is the output that I expect, and I want you to honor it, so that if someone goes into the database and changes something, and someone runs it again, and it breaks that contract, you're notified immediately, right? Another thing, too, is validation. Like, do you need to validate every single row that's coming back from the database? Maybe not. Maybe you just want to sample it. Maybe you just want to do one at a time. Or better yet, I just want to stream it, right? Again, you don't have to write that code. This is all declarative. So in this case, in this example, I have a query SQL. So I'm just going to come to this directory of my GET request. I'm going to create a file. So I got query.SQL. Going to write some SQL, very basic SQL. If you don't know SQL, ask Claude, right? Ask your AI. They can can help you out there. And I'm just going to copy and paste the SQL. This is very simple SQL, but I have some very convoluted SQL. It just works, right? I'm going to go to my app definition, change the response mode to query mode, right? I'm telling the machine, like, I have a query I want you to attach to to my API, you run that, you refresh the page, and now this payload is talking to my database, running that query for me, putting that data in, and feeding into the API without touching any code, without writing any validation, without figuring out if I want to use Zod or Joy or AGV or whatever validation library you want to use, without thinking about like, oh, should I use streams? Oh wait, this is too small. Like none of that, right? This is just, it gives you what it is, and that's it, right? Now there's an ejection associated with it. So obviously it's a machine. It can't do 100% edge cases. It can get you like 99% of the way, but we're all developers. We all know that we want to get our hands dirty. But the code that's generated gets you that, right? It's not formatted, it's ugly, but it's very bare bones. And you can go in there and change stuff. If you do change stuff, you have to make sure you remember to change it to manual so that the machine knows that you went in there and you edited it. So if you run this command again, it's not going to rewrite or remove what you wrote, right? And so this applies to a lot of things. Right now, I'm just applying it to Next.js. But again, just stretch out your imagination. If you have a declarative file for APIs, what else can you have a declarative file for backend development, right? And so that's just a little spiel of the project I'm working on. I'm planning to put it on a secret that you can create a mocking server super cheaply without paying any of these absorbent prices to these servers, to these services. And I'm also working on, let's see if this works. Yeah, right. So we're on Next.js, so why not just take advantage of their page.tsx, right? So this is a very plain Swagger file, but as you build your APIs, right, you get the documentation for free, right? Again, git push, let Vercel build and deploy it, and you get this stuff all for free, kind of trivially, without writing any code, right? So that kind of decouples your back-end and front-end teams to just, who cares about the contract now? Anybody can flip it on to Echo, flip it on to Mock whenever you're ready, right? You don't need to be blocking each other to build these APIs out. Yeah, so anyway, that's the project I'm working on. I don't know what the name I'm going to call it. I call it JSON to Next API, but I don't think that's fair. Naming is hard. But anyways, let me know what you guys think downstairs. Love to get some feedback on it. Yeah, so that'll be it. Thank you. Before we leave, take a look around. Please pick up the trash. Let's keep the spot clean. Please don't forget parking tickets, parking validations. Thank you, the helper bees. See you in the back if you want to talk to them about getting a job. We'll see you downstairs. Thank you.
Thanks.
is simple package